For example, at launch. I expected, after all those years of struggle, finally get to the launch pad, send the vehicles off into space. I thought launch was going to be this joyful moment where finally it all comes to fruition. And in fact, that's not how I felt at all at launch. And a number of my colleagues have said the same thing. At launch, I felt relieved that we finally got them off the ground and NASA couldn't cancel them and JPL couldn't cancel them and so forth. I felt scared because I didn't know if we'd done our jobs well enough. I didn't know if they were really ready to go. And it was hard to say goodbye to them. You know, it was hard to let them go. I'd worked so closely with these things for so long. Man, you put something on top of a rocket and you shoot it to Mars, it's as gone as anything's going to be. And it was hard to say goodbye to them. I think that when the rovers die, my expectation, my prediction is we're going to be pretty depressed. We're going to be sort of devastated. It's going to be hard. We've been doing this for so long now. But I could be wrong about that too. You know, they've done so much more than any of us ever dreamed that it's certainly going to be an honorable death when they die. If they had died young, you know, if Spirit had died on Sol 18 when we thought we'd almost lost the vehicle, that would have been devastating. How it's going to feel 5.5, 8.5, whatever the number is, years into the mission, I don't know. I will be able to get some sleep for a change.
I should point out that my original script for this film was for the rovers to die dramatically at the end. That was 5 years ago. Right here.
How much computing power do we have on the rovers? Our CPU, our processor, was a smoking hot machine in about 1987. It runs at a screaming 10 MIPS. Your cell phone is smarter than my rover. It's C++ and the operating system is VxWorks. Yeah.
Blue shirt.
What are the key scientific and engineering principles that made the Mars exploration rovers such a successful program and project?
Wow. What are the key?
Applicable to human missions?
What are the engineering and scientific principles that made the rover mission such a success? On the engineering side, I would say test and test and test and test. Okay? On the science side, I think the most important thing was, as we went through all the tribulations of trying to develop this mission, our science team always had a consistent vision of what we were trying to accomplish scientifically. You know, there's a lot of flavor of the week of this scientific discovery and that scientific discovery on Mars, and it's easy to let that pull you off course. We always knew exactly what we wanted to do, and we developed a suite of scientific instruments that worked together as a set to accomplish that job. I think there's one other thing too, and that was management that didn't flinch. And I have to, you know, I sometimes speak a little bit disparaging of NASA, but I have to give NASA a hell of a lot of credit. And Orlando Figueroa, Ed Weiler, the people at the top of the Mars program when we were developing these missions. We ran into all kind of trouble. Okay, you saw the exploding parachutes and all sorts. It was way worse than that. I mean, George made it look bad, but believe me, it was even worse. And these guys not only had the guts to keep going when the last two missions had failed, but they had the wisdom to see that unless they gave us more money, we weren't going to make it. We signed in blood at the start of this mission that this thing was going to come in at $688 million. It launched at $800 million. They gave us the money that we needed to get the job done, and we wouldn't have made it without them. So you got to have some management with some guts as well.
Last question. You, sir. Right there. This gentleman with the red thing in his neck. Loud voice.
You mentioned that the solar arrays had more power than you needed. I'm wondering how much power did it take to get these rovers around Mars on a regular basis?
Okay, how much power do the rovers take? When the rovers are absolutely clean, brand new, straight off the showroom floor, they put out 900 watt-hours of power per sol. That's enough energy to run a 100-watt light bulb for 9 hours. And that's for everything. That's for driving, that's for taking the data, that's for transmitting the data to Earth, and importantly, that's for running the heaters at night that keep the inside of the vehicle warm enough. The vehicles are very, very active at 600 watt hours. We can keep them pretty busy at 400 watt hours. You get to about 200 watt hours and they're pretty much just sort of in survival mode. If it gets significantly below 200, you probably lose the vehicles. So that's been about how it goes. But these, I mean, I was making fun of the computer on board, but one of the virtues of that 10 MIPS processor is that it draws very, very little power. And that sure helps when all you got is solar arrays to power you. I guess that's it. Thank you very much.